Today we're going to do some linear story problems. So I'll show you a few, and then you have a few more to work on. So a jogger running at 9 miles per hour burns approximately 14 calories per minute. So first, let's define our variables. So we want to write a linear equation for the number of calories burned by the jogger in terms of the number of minutes run. So the in terms of piece is the independent variable, so that's our x. So x is number of minutes. And y is number of calories. The number of minutes will tell us the number of calories, so input, output. So then our equation, y equals, essentially, our slope is 14 calories per 1 minute, so it's just y equals 14x. And then after 32 minutes for part B, that's what we want to figure out. Okay, so use your equation to find the number of calories that the jogger has burned after 32 minutes. Y equals 14 times 32, which is 448 calories. For number 2, a building contractor estimates that the cost to build a home is $30,000 plus $85 for each square foot of floor space in the house. So we want a linear function that will give the cost of building a house that contains a given number of square feet. So y is going to be our cost. So then x is the number of square feet. Y is cost in dollars. So we want to come up with a linear function. So y equals mx plus b, and our slope is going to be our rate. So $85 per square foot. So our slope is 85. So mx plus our y-intercept is essentially our initial value, which means even when you have 0 square feet, it's going to cost $30,000. So our y-intercept is $30,000 because that's our value when x is 0. And then we want to, in part B, use this to determine the cost to build a house that contains 1,800 square feet. Well, y equals 85 times 1,800 plus 30,000. And this equals $183,000. I'll have you do number 3 on your own, and number 4. I'm actually just going to skip to number 5. So a manufacturer of economy cars has determined that 50,000 cars per month can be sold at a price of $9,000, and when they cost $87.50, the number of cars would increase to 55,000. And we want to determine a linear function that will predict the number of cars, so that's our y, that would be sold at a given price. So x is going to be our price in dollars, and y equals the number of cars. The idea is that the number of cars sold is dependent on the price. So our y is our dependent variable, x is our independent. So in this case, we don't really have a slope, but we have two sets of values, 2 points. So we have 50,000 cars, at a price of 9,000. So that would be the point 9,000, 50,000. And then we have 8750 and 55,000 cars. So 8750, 55,000. From there, now we can find our slope. So it would be 55,000 minus 50,000 over 8750 minus 9,000, which is 5,000 over negative 250, which is negative 20. Since it's a slope, it's over 1. And our y was the number of cars, and our x was dollars, the price. So basically, you sell 20 fewer cars every time there's a $1 increase in the price. Okay? kind of interesting. You can graph it if you want to see after we come up with the equation. So then we have our slope. We don't know our initial value, so we have to find it. So y equals mx plus b is our general formula. You can use either point. We use the first one. So our y value is 50,000. Our slope we just found, it was -20. Our x value is 9,000 plus our b that we're trying to find. So we have 50,000 equals -180,000 plus b. Add 180,000 to both sides. B equals 230, not 230. So B is 230,000, and the y-intercept is, this is kind of weird, but basically if you made the cost $0, you could sell 230,000 cars, which is kind of odd, right? The model kind of falls apart, but as far as our equation, we can still do that. So then, again, our y-intercept in terms of cars. So now our equation is y equals -20x plus 230,000. So if the price was 8,500, y equals -20 times 8,500 plus 230,000, which equals 60,000 cars. And again, if you compare these numbers, if the price was 9,000, we sold 50,000, 87.50, we sold 5,000 more. When it was 900, we sold more than that. So it should be fairly logical.